This video is for August 11th and August 14th. It says 9th and 10th. We started this on the 9th and 10th, but because we got books, we didn't really get through too much content. I'm going to summarize quickly what we did on August 9th and 10th, and then I'm going to go into what we did on the 11th and 14th. So on the 9th and 10th, we looked at the radian measurement. We looked at circumference is 2 pi r, and we wrote that pi is 3.14. So if I multiply 2 and 3.14, that's 6.28 r. Now what this is telling us, if that's the circumference, then what that's telling us is if I have a radius, let's call that r1, then if I bend it around this circle, then I can bend it around the circle 1, 2, 3, 4, 5, 6, and that 0.28. That's what this told us. And what's happening is it's creating angles. So if I draw down a line, I can create this angle. And this is helpful because now we can define angles not only in terms of degrees, but also in this thing that we call radian. Now, we talked about how many times around the circle. This 6.28, that was a number that kept coming up, showing up. But where the 6.28 comes from, again, is the 2 pi. So if we're asking how many radians does it take to make it around an entire circle, we're really talking about 2 pi radians, okay? So 2 pi radians is going to help us get around the entire circle. This is helpful because if we know 2 pi, then we can think of, all right, all the way around the circle is 2 pi. What about halfway around the circle? What about a quarter of the way? And all those things. Also, I passed out like a big circle, which we're taking all this down. I'll post that online. It might be good to, if this is our big circle, then 2 pi is going to be out here because that's that's 0. That's where we start. But 2 pi is also there because that's all the way around the circle to get back there. I also have it posted in the room, so if you don't want to do that, you can, whenever you come back into the room, you can have all of those degree and radian measures. But I'm going to keep going. Go to the next page. So again, all the way around the circle is 2 pi radians. This is all the way around. So in class, I gave students time to figure out, well, what about half of a circle? What about a quarter of a circle, an eighth, and a third? And what students said is, well, if it's 2 pi to go all the way around the circle, so 2 pi is all the way around, then to go halfway, 2 pi is all the way around, half of the circle should just be pi radians. And that's true. So halfway, if we go 180 degrees, that's going to be related to pi radians. And then we picked up from there. So then we talked about a quarter of a circle. Well, what students noticed is if I take 1/2 and multiply it by 1/2, some students did this. I'm not going to go through all of the ways because that would take too much time. I'm just going to show like the quick, efficient ways. 1/2 times 1/2, that gets me to 1/4. But if a half a circle is pi, I can put pi here and multiply it by 1/2. Well, if I'm multiplying a fraction, I can rewrite pi as pi over 1. And then if I'm multiplying these two fractions, I multiply straight across. So that would be pi over 2. I'm going to scrap this. So a quarter of a circle is pi over 2 radians. An eighth of a circle, similar thing. We say, hey, a quarter, if I multiply that by 1/2, that gets me to 1/8. So a quarter of a circle, we just said is pi over 2 radians. I'm going to multiply that by 1/2. Pi times 1 is pi, 2 times 2 is 4. So an eighth of the circle is going to be pi over 4 radians. And then we got to this third of a circle deal, and we said, hey, well, what about a third of a circle? Well, what we can do is if 2 pi, and some students did this, they said 2 pi is the entire circle, I want a third of it. So I'll multiply that by 1/3. Again, if I'm multiplying these fractions, I could put this over 1, and that would give me 2 pi over 3 radians. Okay. So if you need to pause, rewind, whatever you got to do, but the goal of this was to show that we can figure out all the radian measures on our big circle, but just by multiplying by fractions, doing something similar to what we did here. That's the goal. Now, on our circle, if we wanted to kind of recap, again, this is 0 and 2 pi, because 2 pi is all the way around. If I go halfway, we said it was pi radians. So halfway would be pi. A quarter of the way, so if this is halfway, a quarter would be here. That's going to be pi over 2. And then an eighth of a way, which is a quarter, halfway of a quarter is an eighth, pi over 4. And we also said that 2 pi over 3 would be here. I kind of gave that without reason, but we could also figure that out. Now from here, what we did is we developed the rest of the unit circle with the degrees and radians. I'm not going to do that on here. What I would encourage you to do, it's up on my board in the room. If you weren't here, take a look. If you have questions about any of the degrees or radians, great. This is not going to be super important. I just want to show where these come from. We won't use this per se moving forward, but it is good to know like where these things are coming from and how to get there. So if you haven't been to class, come to class, look at the board, and see how all the other degrees and radians. If you have questions about those, please ask me. Now I'm going to stop this video here, but on the next video we'll talk about conversion formulas for degrees and radians, and then also start to look at coterminal angles.